create basic chatbot, okay, through LLM. If the session doesn't permit us to complete the entire thing, uh, we will be, you know, we will be probably dividing this into two parts. Okay. So first, let me start the screen share. First of all, one question to you all: what do you understand by large language models? I want to keep the session interactive. I want everybody to take part in it. Yes, I'll be using PDFs. Can somebody tell that what do you understand by large language models? Is my voice not clear? Yeah. My question is, what do you have been hearing about GPT? What do you mean by large language model? Do not copy it from Google and tell me the answer. And tell me, what do you mean by large language model? Anybody? Have you heard of it? Large language model. See, guys. So first of all, before understanding large language model, you need to understand a revolution. There was a paper that came in. The paper name was. Let me write it. There was a paper. There was a research paper which was published by Google Brains team in the year 2017. The paper name was "Attention is All You Need." If you search this paper, you will be visiting a link known as archive.org, and you will be able to download the paper if you ever want to read it up. Obviously, you need little bit of stats knowledge and machine learning knowledge to understand this. Okay, attention is all you need is the paper that actually revolutionized the entire spectrum of AI, and entire evolution of AI took place because of this paper. But that evolution started taking took place in a commercial manner, but 2022, because of something known as LLMs, standing for large language models. Okay. So this happened in 2022. They released after ChatGPT came out, as a more commercial adoption happened of this AI. Before this, also AI was there. Okay, but we were not. We as a developers and we as coders and everything, we were not getting that attention. Okay. Uh, so now let me go back. Before coming to large language model, what existed between 2022 to 2020? Uh, uh, 2017, basically. In this 5 years, what happened? So attention is all you need actually created one concept known as transformers. Transformer is basically an architecture. The architecture looks something like this. So this is what a transformers architecture looks like. In this, you have an encoder and a decoder. The encoder takes the input in a form of some language, or let's say some sequence. It could be English, it could be Chinese, it could be anything. The goal of this encoder, let's say you're giving the words in English, and you want the output, final output in French. So let's say you're doing a machine translation. Okay, so you give the input in English, and the encoder's goal is to understand these English and create a intermediate state which is known as encodings. So encodings is like a matrix. Encodings are matrix, big matrix values. Okay, that is created by encoder. Encoder's job is to take this English and create these encodings. Decoder's job is to take these encodings and create the French sentence. So what is the goal of encoder, guys? If you could repeat, could anybody tell in a different way? What does encoder do basically, and what does decoder do? Yes, encoder's goal is to create, it embeds the input center into numerical vectors or matrices. Okay, and decoder's goal is to take these vectors and create their whatever language you want to create, whatever way you want to translate. It could be even question answering also. Question is also a sequence of words, and answers are like the answers that you get from the question. Encode is like inputting a data. No, encoding is Sayed, encoding is like you take English and convert it into their numerical format. English words, sentences, convert into their numerical format, because numerical format is what the system understands, your computer understands. Okay. Okay, now comes to the main part. Is in between encoder and decoder there is a technology, there is a concept known as, in between this encoder and and decoder, there is a concept in between, something known as attention. So what is attention? Attention is basically is a concept, that's what was created in this paper also. Attention is a concept in which, you know, every words understand while translating. Let's say I'm translating, uh, how are you, how to, how in French. Okay, let's say some a b x y z in French. Okay. Okay, so while translating this word to this word, this word to this word, what is my weightage should I give to this word and the next word, how are you, and to the next word. So while I'm translating how to the French meaning of how, okay, where should I give the most amount of weightage, guys? On which word should I give the most amount of weightage in their English format? Please write down in the chat. How only, obviously. Yeah. Okay, so let's say, for example, let's say I'm doing a Hindi to English to Hindi translation. Okay, I am saying I love playing cricket. Okay, let's say when I'm doing mujhe cricket khelna pasand hai, when I am doing the word pasand, where is the most amount of weightage that is given? On which word? In English, which word should I give? Love. Definitely love. Love is the word that I should give more amount of weightage. So so attention, now do you get it, guys? This is a thing that exists in between. This is a layer, that attention layer that exists in between encoder and decoder, which gives you that contextual understanding key. When I am trying to convert this word to this word a to word a in other language, what is my weightage, highest amount of weightage that I should give? And this is not only for that particular word. It can see, sometimes see, when you are saying something in English, let's say you say I love playing cricket, I love playing cricket, there are four words. If you do it in Hindi, mujhe cricket khelna pasand hai, it's five words. Okay, so sometimes you might think that okay, while translating it will obviously give weightage to how only or love only, right? But it is not the case. Every time you do not have the same number of words in the other language. Okay, so that's the thing. So you have to understand that uh, it is actually trying to understand the context while translating certain words to certain other words. What is my context weightage that I should give? Okay, so this is the entire concept of transformers. Transformers has encoder and decoder, and in between they have uh, attention. Just hold on, guys. There is somebody at the door. Yeah. Okay. So this is the concept of encoder and decoder. So with that, transformers was built, and transformers first was built, and everything came from Google only, basically. Okay. The concept and everything, the all understanding, these are all created by Google prodigies. Okay. So now, uh, transformers resulted in Google creating a model known as BERT. But is based on the similar transform architecture which I told you: encoder, decoder. There is attention in between. These decoders can be kept, can be like, you can take this decoder, you can attach different decoders. Decoders are, detached, basically. Okay, so what does BERT full form is? Bidirectional encoder representation of transformers. Okay, so all these things which I'm talking about was happening between 2017 to 2022. Okay, all these things were happening in between. Okay, BERT, and then came GPT. Okay, so what does BERT do? BERT will do the same thing. Okay, this thing, whatever I was explaining, that's what BERT does. But you can change your decoder depending upon your need. Let's say you want to do a French translation, you will put a decoder which takes embeddings and convert them into French. Let's say you want to do a Chinese translation. What you will do is you will put a Mandarin decoder. Let's say you want to do a question answering. You have questions and you want to answer them. Then you will put a answering decoder. So depending upon your need, you can put your decoder. Okay, it is detachable. Okay, that's what the concept of decoder is. Majorly, BERT is all about the encoder. Decoder, you can just whatever you want, you can put on top of that. Okay, let's say you have a sentence and you just want to classify them into sentences positive or negative. If you want, you can do that. You can put that decoder also. So this is what BERT does. Okay. So BERT was the first thing that revolutionized this entire paper and concept. All these papers and concept are good for data scientists and AI engineers, but how as a commercial people will use it? They use when they use this BERT. When was this BERT applicable? The BERT was used first time in Google search. When you used to search, let's say how much is Shah Rukh Khan's. Let's say if I write how much is Shah Rukh Khan's, automatically suggestions come. How much is Shah Rukh Khan's house worth? How much is his net worth? How much is his first film's budget worth? Okay, everything comes. All those suggestions that you used to see was based on BERT. Even when you were writing mails, the moment you write a word, next three, four words come as a suggestion. All those things were designed by BERT. Okay, so it was BERT which was working when you didn't know, when you were not aware of it also. So everybody clear till now what is happening? Yes, based on the sequence, it will predict. So now what happened is, see, BERT has happened after this GPT came. OpenAI came with GPT-1, GPT-2. What does GPT does? GPT basically, in BERT, the majority part is encoder. You have multiple encoders over here. And decoder, if you want, you can put it, or you can just create encoders. In BERT, you have multiple decoders. There could be one encoder, but there could be multiple decoders. Everybody is doing other task. Okay, BERT is all based on decoder. Okay, there is an encoder, there is an input, that also happens in BERT also, in GPT also. So that's how GPT 1, 2, 3 was evolving. Then came ChatGPT. Okay, that is where OpenAI hired a lot of prompters, and they created prompts. They created artificial prompts. They rank those prompts as per the actual. They rank those prompts as per the actual answers. Okay, and they trained a model which can, using reinforcement learning, which will be able to predict based on the search query you make. It will give you the right relevant searches, because they have been trained on petabytes of data. So previously, this BERT which you are seeing was a language model. This BERT you are seeing is a language model, LM. It is a language model. Okay, because it was trained on the entire Wikipedia dataset, and 2500, I think, to yeah 2500 million uh sentences, I think so. Okay, that many sentences was Wikipedia's data was trained. BERT was trained. Okay, so basically it was trained on the entire Wikipedia data set. That was a language model. GPT, Chat GPT, GPT 3.5 onwards, it's where the large language model evolution started, and that's where, and then rest has been history. Last 2 years, so many developments has taken place. Okay, then Gemini came out, then Google first released Bard also. Okay, it was an improved version of their BERT and a mixture of large language model. Okay, so Bard, and then they named it to Gemini. Now they are releasing their short quantized models, small models known as Gemma also. So all these things started taking place. So this is the entire history of transformer, from attention is all you need paper till here. Okay, now lot of companies have released their models. Okay, lot of companies have released their model. There are two types of models that you will see in the industry. Okay, so first is a proprietary model, prop models, that is coming from company itself, from the organization itself. You can use them in a form of a API. Okay, they are Gemini, you have OpenAI. Okay, and then other ways, there are other models which are open source models, which you can use, and you can use it in your system itself if you have the infrastructure. Okay, open source OS models, basically open source models. You have your Llama. Okay, you have Mistral. A lot of Mistral open source models are there. Okay, others are also there, definitely. Okay, and beside that, over here you also have some of these models, like Cohere as well. I use Cohere, and I will help you understand everything on Cohere only. Okay, so these are the two types of models we'll be referring to Cohere, because prop models actually does better than open source, because prop models are costly in nature also, and prop models are, you do not have to worry about the infrastructure cost and everything. Prop models, but they are, in general, they are costly. Okay, okay. So now comes to uh something that we want to build from today and next days. This thing is basically a rack system. See, this system has becoming a lot of very popular now. You are seeing that rack systems are becoming very popular. Many people are building this, because other ways. What is rack system? I'll explain everything. Today I will mostly do the explanation. Next day I will continue on building the entire application. Okay, and continue on building the entire chatbot. Okay, so in what is the other alternative to rack systems? Okay, So first of all, let me explain you what is a rack system. Okay, rack system basically what you have is, let's say if you want to ask a question to ChatGPT. Wait, guys, just a minute. Let's say I want to ask a proprietary question to ChatGPT. Let's say I have given you all an uh, a contractual document. Okay, what is the contract date of the document between Anirban and XYZ about the house 341 Sarjapur Road, Bangalore. Let's see what it comes. See, it is giving a generic answer that you have to refer to the document. This is where you will find. But did you get the answer? Did you really get the answer? Tell me. So let's say I have a company. Let's say I have a law firm. Okay, and I am creating a chatbot for my users. Okay, whenever they come and whenever they come and they want to verify certain documents, they can do it in this chatbot. Okay, so if I build a normal chatbot, if I build a normal if I ask them just do it on ChatGPT, it won't work. What they will have to do, what they will do, what is the most easiest approach that you can think of? The most easiest approach is they uploading this PDF document, this contract document onto ChatGPT. Okay, and asking the question from there, right? But then what is your IP? What is, as a law firm, what did you build? You didn't build anything. You are just, going back to ChatGPT only, right? So what if you can borrow this technology and use it for your own system? If you want to use it, what you'll have to do, you'll have to train your model. You have to train this entire GPT or whatever you want to use on those law documents, and next time if you give it, it will be able to answer, right? That is the most easiest thing you can think of. Yes. So either you can do like this, either you can train the model, either you can train the model known as fine tuning. That is the best approach, obviously. Okay. Fine tuning is computationally expensive, time taking, requires more expertise. Okay, sometimes it requires understanding of the model that you are trying to train, because these are trained by some other companies. So you have to understand their architecture, their parameters, and everything. So expertise is required, definitely. What you can do on an ad hoc basis, on a more easier system, you can build something known as a RAG system. A RAG system. Okay. So what you can do is you can build a RAG system. What does RAG system does? Let me explain. Okay. So RAG system will take a PDF. Okay. The PDF have multiple pages, multiple lines of words. Okay, and it has multiple pages also. RAG system will create something known as, it will take a section of the page. Let's say this much, this much. Next page also it will take certain section. Let's say this much, this much, this much. Every section it will take. After taking all these section, it will create something known as a vector database. A vector database. So a vector database will have all these sections value in a matrix format. Vector database is basically a database of matrices. This word, this part will be this. This is a matrix, okay? Let's say 1.2, 3, 4.2. Values are written in this format. Okay, so these words have been taken, they have been, a vector has been created, and they have been given. So all these things have been done using an encoder only. Okay, the encoder that you have learned. Okay, let's say a encoder has been used to create them. Okay, so you have such vectors kept, okay, of every section, this section, every section will be kept. Okay, so next time I will create a chatbot, okay, where a person will search with a term. Let's say what is ABC. Okay, this part vectorized will be vectorized like this format. Okay, this part will also be vectorized in a matrix format. Okay, let's say 1.26 and like this, and they will be searched against all these stored vector databases, and whichever will give the nearest matrix. Okay, this is the most closest I feel from the search that has been made. Once I have found this part, okay, that means I have found this section. If I have found this section, I can give this section, this part, to ChatGPT and ask, give me the answer for this question from this section, and build a UI on top of that. Did you all understand what happened? So what did I do? I augmented the answers. So if you ask ChatGPT, you will get some answers, but you are getting generic answers. If you want to augment as in if you want to increase, if you want to increase the amount of answer that is more specific to your need, you have to create a RAG system. This is what a RAG system is. Your large language models are already trained on petabytes of data. Petabytes, 1 petabyte means 1,000 terabytes. Okay, so petabytes of data. What you are doing is basically you are referring to these petabytes of data, okay, with the help of a vector database. You have a vector database which actually stores these petabytes of data in their matrix format, whenever in chunks, in particular chunks, certain sections, section basis, okay, segmented format. Now whenever I am searching, when a user comes, that user's words are also converted to their vector format, and they are searched against those metrics, and whichever matrix gives the nearest, that chunk will be returned to LLM, and the LLM will be asked that can you generate an answer of this question from this section. Did you all understand, guys? Did you all understand the entire architecture? What just happened? Okay. So this is known as a rack system. How many of you knew about rack systems? Tell me, guys. Okay. At this generation, guys, everybody should know at least a RAG. At least a RAG system you should know. Even if you don't know everything about LLM, if you don't know fine tuning also, if you know RAG, I'm telling you guys, lot of interviews clearing will be easy. Okay, because RAG has become so much commercially popular, so much adoption wise it has become so popular. Okay, because people were not able to do fine tuning and all these things, they build RAGs. Okay, so that's what I'm saying, that RAG is the basic thing that you all should be aware of. You should know a RAG architecture to build a chatbot on top of any documents or anything. Okay, now this is just with respect to one document that I will show it to you. In my company, I do this for thousands of documents. Okay, let's say you want to create a search systems. Okay, like you want to get the relevant document being searched. Let's say, for example, I will give you. So now I'm sharing with respect to PDF. Let's say you want to do it with respect to HTML. Okay. Uh, let's say Stack Overflow. In Stack Overflow, so many questions and answers are there, right? Now, every question and answer requires a lot of searching by you. Okay. And Google is somewhat doing it. Google is not using a vector database. They have a different concept. They have a graph concept. Okay. Of getting you the right. But let's say you take all the Stack Overflow pages and you create this kind of vector database of all the pages, vector database of Stack Overflow pages. Okay, in chunks, divide the page into chunks. Okay, small chunks. Create vector database, and then if you want to search, you can create a search a bar like this. Search, get the create a vector data vector of this search, and then find the distance between all the vectors that you have stored in your database. Whichever is the nearest, that will give you the answer. Then you can get the actual answer from the actual Stack Overflow answers. Okay, so people are building lot of application on top of these. Okay, so this is the actual level of development that is happening in the real world currently. And and you as a aspirant, AI aspirant, should know at least a rack system. Okay, this is very basic. You all understood this probably in 40 minutes without understanding a lot of deep learning, without understanding a lot of transformers. You still have understood, right? People who were new to this concept, a lot of people have understood, right? So that is why RAG has scaled so much. Even people who don't know ML also, they also understand RAG. Software developers are using RAGs now, though they do not have any idea about machine learning. They are building RAG system. So at least a RAG system you should know. That's why this webinar was kept, to understand these RAG applications. So today we understood the entire architecture. Next day I will show you application, how to build this, and we will divide this webinar into two parts. And I'll show you how to build this entire RAG application from scratch. And then then we will give you a I'll give you an assignment also, how you can build it for multiple PDFs also. Okay, got it guys? Understood guys? Lot of learnings today about rack systems. See, today I have explained the architecture. Next day I will go to the code part. I am done with I have the code part today also, but it will take a lot of time to help you explain the code itself. Okay, so next day I will go with the coding part, the entire coding part. Okay, the entire architecture. Okay, Shashwat, the session will not be tomorrow. It will be some few weeks after few weeks. Okay, always it happens like that only. Okay, so you wait for a few days, you will get. Okay. Okay, guys. With that, guys, I will end the session here. Okay. Bye, everyone.